There's Cameron even now. Hey, it's Coffee Compiler Club here today to talk about typing systems and theory of typing in echo versus ISO recursive types, or anything to do with languages and compilers and compiler runtimes and typing systems and the like. Everyone's been recorded live. We'll be up on YouTube within a couple hours to a day, depending how quick I get around to it. So right before I started the video, I was trying to explain what goes wrong with the general typing rules if you get away from nominative typing, which is what Cameron and I were talking about yesterday and this morning, and whether or not ecstasy falls into this camp and do you want it to. And I don't know if Java falls in this camp, and I guess I think the answer is no. Oh, and then Manas says, here's the paper I'll be looking for, and I wonder if you got it. This should probably go in the links. Yeah, this is the other paper I found. There is yet another paper that is exciting. I found this one. That's the unsound one, but I think that's the one that just says you have to have null checks in Java. If you use generics, the type erasure, the types are all gone. You compile Java C, get some class files. Then you mix and match class files, ignoring Java C, so you don't get Java C gets a chance to report your error. Then the runtime gets.
Just for the record, the paper is wrong, but
okay, that paper.
The type system is unsound.
That's from Nara Yemin. She proves that the Java and Scala type systems are unsound because of no.
It's not that the type systems are unsound. It's that the implementation had a bug.
Yeah.
Okay.
There's a difference. The one is a design flaw. The other is an implementation flaw.
Yes.
Oh, okay.
Yeah. There's another paper.
You can fix implementation flaws.
Yeah. When did that get fixed by? This paper's kind of old. So it's surely been fixed.
I asked Brian. He couldn't remember. He wasn't even certain that the fix was already in. It's such like a squirrely corner case anyway.
Well, that's all fine, but the fixes should be easy. I'm assuming the fix is that the compiler has to insert too many cache checks because it's generics. They got type erased, so the runtime gets shit for types, and so he just.
Yes, that's fundamentally the problem. Is that you have some step that gets assumed to have been done already by someone in the verification process, and the guy on the left didn't do it, and the guy on the right doesn't have the data to do it, or something like that.
Exactly. Yeah, the guy on the left did it, but then you threw his results away because you took class files from multiple unrelated things. That was one of my long-standing bugs with Java C on loader constraints. If you mixed and matched files from unrelated Java Cs, you could bypass the loader constraint check and then make a string be not a string, and then you could peek and poke string contents, and immediately you broke all security then. And I gave an example, filed a bug with Sun with complete example, and a decade later they came back and said, hey, is this still a bug? And I said, well, let me follow the link you sent me to the bug case. Let me pull up the bug test case I put in there. Let me run it right now. Oh, look, it still happens. Why did you bother to poke me without actually running your own bug case I gave you a decade ago? Geez, fine. No, I was trying to come around to whether or not you're going to be ISO recursive or echo recursive, I think is the dividing line between whether or not you have to have a DFA minimization algorithm or not. And the general rule is if you're nominative, it's all fine and dandy because your names are equal or they're not, and that's the end of the typing question. So we can throw up. Let me throw up.
No throwing up online.
Yeah, okay. No, I have reasonably ugly looking test cases here. I'll step through one or two in a row, and then I'll step them up evenly. And then I didn't get I didn't get the one that I'm certain is going to cause troubles. So I don't know if I have an actual, like, your life sucks test case in front of you. Let me hit share screen, Google Docs, share. Here we go, blah, 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 code for copy. Okay, so here is a bad paste from Discord. Let me try pasting again here. Okay, so here's 3 list classes. They each have a next field which has the self value. Is there some function I can do that would take all 3 of these and get the next field out and preserve the type? Mark, oh, here's Mark showing up now. That's good.
Is this a real type?
These are, call us fake Java things, right? The answer is
The
list
problem
in
is
has a
right
next
here.
type list in.
The problem is like right here. It's object.
No, it's not nothing to do with object. I could replace object with string or anything else. It has nothing to do with nothing on object.
Okay.
The problem here is that if I have an item of list one in front of me, and I'll call this X1 is new list one. I put some stuff in. I don't care what it is. And then somewhere I'd say X1.next. And the answer is, what is this type? It's obviously a list one or no, right? Okay. So let me try something else here. So here's a Y1, which is random of X1 and a new list two. What is that type? Well, in the land of Java, he says no, because list one and list two are different. It's nominative. You can't do that. This is type error. And on the other hand, Y1.next is fairly well defined. Both these guys have a next field. But what is the type of Y1.next? Well, it's either list one or list two, and it's sort of well known to you and I, but there's nothing the type system will let you do that with. Okay, so let me go get rid of the nominative typing that says list one and is a list two by throwing out, and this will be some ecstasy code here. Interface list has a list question mark. Oops. Okay, here's Cameron like dumping this guy in. I can leave his case. List Y is a list Y, and you're going to
listy.
Yeah,
it's listy. Okay.
It's listy.
It's listy.
yes.
Fine. The question mark means optional or nullable.
Say again.
The question mark means optional or nullable.
Yeah.
Nullable. It means it's a union of nullable or
listy. Oh,
listy. Yeah.
For purposes of my grief here, you can assume that this is a C language and it's using an actual no hardware bits, and I don't really care. That's not part of the issue.
So I'm not really. I'm assuming we are going to the point to the problem, but if you don't allow the type to be null, you can actually not. You can terminate the type. It will actually.
I can only make
it will be list of
lists.
list of list of list of list. You cannot terminate it.
Right. So I'm going to get rid of the null and say I only make circular lists, however I make them. Magically, somebody poofed, gave me a circular list. Then the null question goes away. But we can bring the null question back. It doesn't impact the typing problem at all.
I'm not sure what the distinction between optional and null is. To me, they're both the same.
Yeah, they're not. Right. For this purpose, exactly for this purpose, they're all the same.
They are the same.
In some languages, for whatever reason, they want to create an extra object to represent nullability.
Yes.
Oh, yeah, I don't like that.
It's hugely expensive if you do it wrong, and some languages demand that you do it wrong, and then Rust claims they get you an optional for no cost, which because they're using a null under the hood. Assume one of those things going on here. It has nothing to do with the problem in question. The real question here is when I say list one dot next, what is that type? List Y, ly1 is a what is ly.1 dot next?
I mean this.
So because you're calling it through an interface, your compile time type for that is listy.
Okay. So we've
runtime type is list
right. So we've come to the realm of now we have structural types because we're using interfaces, not nominative. Yeah, the null just confuses the issue here. I would just put a question mark and walk away. Don't make it a ecstasy special thing here. We're just faking, and null is not anything to do with the problem. Okay, so in this case, I have a single recursion point that's itself for generically, but I can make an arbitrary graph of interfaces that self-refer and an arbitrarily complicated set of lists that self-refer. And then you ask the question, this thing is a list Y. The typing system has to answer that question.
Yeah, but in this case, you couldn't have assigned list one to listy if it didn't pass ISA.
My point is that I'm going to make your ISA test arbitrarily complicated, and then you can't solve it in any sort of reasonably easy way. So I'm going to
Understood.
try a round 2, which is slightly more complicated, and I'll paste it down here.
Well, I gave you the ABA example.
Yeah, I'm going to pull about the ABA example.
Mhm.
And then there is a version that follows where you get arbitrarily large, complicated things. You're asking, are these two type graphs equivalent? And as soon as you have an arbitrary type graph you're asking for equivalence for, you have
I
to have
will
a
tell
DFA
you,
minimization algorithm.
anytime I have to go in the debugger through ISA, I automatically punt the problem to Gene at that
Yeah.
point. Because
This
it goes so nested and so
Right.
recursive that
Yes.
I simply I hang up the
If
phone
he
at that point.
fails to have a DFA minimization algorithm, then I can write a type that will stack overflow him.
So we detect the recursion, and that's where we make the decision.
I can totally write you a type where you cannot detect the recursion up front.
Okay.
Or if you detect it, you will throw a false negative. You'll say these two types are not equal when they are. You must have a DFA minimization algorithm. Oh, what the hell? Sorry, more people are piling in, which is all good. Oh, it's Jim twice. That's my confusion.
Who's Jim twice?
Yeah, exactly. Well, it was Levo for 30 seconds, well, for 2 minutes before he could join. Jim twice is, Jim once and Jim again. Because New Zealand. Where did Jim go? Here he is. Fine.
In New Zealand or?
Yeah, well,
Thailand or
last I
Malaysia?
heard, there was some comment about being New Zealandish, and therefore his,
Well,
and
it's
3 in the
some-
morning and internet was sucky. So
It's somewhere down there.
Valley.
yeah, he's not
Bali.
necessarily terribly close. Hey Jim, looks like Discord.
Jim said
visits.
Bali.
Zoom claims you've made it.
Yeah.
All right, I'm gonna try again here. So in this case, I've made a pair of classes that self-refer. I made another pair of classes that self-refer. I made a pair of interfaces that self-refer. I pick randomly from the pairs, and now I'm under the interface A's and B's. And I go back and forth between A's and B's arbitrarily randomly here. Hey, just call next, and I'm flip-flopping.
But
And then, is this question allowed? Can you ask the question that they both got a dog field? And I don't care what the answer is, other than, I can arrange for it to be true in Python. It's not arbitrarily false. And the question's well specified. And here I have a graph of 2 things. And I go again here, hey, here's a link. Link takes just some age, some dog. They both have a next field. So I can randomly sort nexts on them, both. And then at some point ask the question, did I end up in the same spot? And is this question even allowed? So it's all about an is a test. And now I have a graph of 2 things, but I can make arbitrarily strongly connected components graphs where you have 17 on the one and 5 on the other, and they should be equivalent because there's no way to walk between the different members of the 2 without coming across a place where you could take a walk in one and not the other. This gets you an arbitrary graph equivalence, which requires DFA minimization. Failing to have a DFA minimization, you'll either arbitrarily throw a false, say they're not equivalent, or typically you just recurse infinitely and you stack overflow. You get one of those 2 answers. So I did it with 2 here, and you could ask the question, do you allow this and are they equivalent? But I can make it with, like I said, 17 and 25s, and a good tight fuzzer would give you like a very large.
So I mean, keep in mind that I didn't write every line of our code, so I can't. Answer definitively.
Right.
But yes, this is something that we handle. And we, as I told you, when we get to that end point where we could go left or we could go right, we chose to say return false.
Okay, so you throw a false negative, but it's not a false negative. I'm sorry, you throw a negative.
We choose to say that they're not ISA, but
Okay.
we used to choose to say that they are ISA, and we just made it more conservative on purpose.
Yes. Well, I'm asking what is your language design choice? That's fine. If you say false, then
Yeah.
I have
So I wouldn't call it a language design choice. The language design choice was to go through that graph and end up at that point having that question, and to keep the complexity down, to keep the entropy down, we chose it in the absence of any indicator that we should do the other way. We chose to keep it simple. And
Yeah,
we
okay,
said
so
return
that's a
false.
design choice, which is a perfectly reasonable one. It
Right,
also,
but I wouldn't say it's the reason I'm kind of hedging on saying it's a language design choice is that,
you can change your mind later on this one,
exactly.
but
That's
you can't go
kind of
the
what I
other
meant.
way.
We just didn't have evidence that it was valuable, and therefore, we
Yes.
disable things that we don't have evidence are
Yeah,
valuable.
that's fine. So the one where you say false at some point means it can be solved with a standard recursive descent on a graph with a visit bit to handle the points that you've got a DAG. You don't have a cycle, you have a DAG. You walk
And
a
again,
DAG.
I don't recall the implementation of how it determines the cycle, so I can't.
Yeah.
I can't comment.
Yeah, I bet you your determining of a cycle is that you see that you visited yourself already.
It's quite possible.
And if that case, that is the recursive descent with a visit bit. And the usual visit bit is I did some fix up on it. And when I come to visit it again, I see that I've already done the fix up. That's my visit bit. And I don't visit it again. So I just unwind. And that will throw false positive, false negatives. It'll say no when they're clearly otherwise type equivalent. And I'm
Yeah,
headed down the.
It's an area that's outside of my vision. So
Okay, fine. No. It's a good choice. And I went the other route in AA because I was always doing the most general case, and I ended up proving to myself that I absolutely must have a DFA minimization algorithm, and I can write the type that'll force that case. These two types will look the same in all ways, except any recursive descent will fail on proving that they are equivalent. It will throw a false positive. You must switch over to a DFA minimization algorithm. And that's the test case I'm heading for here. I'm not quite there yet, but I'm getting close.
Yeah.
And
now, and keep in mind, by the way, if you scroll back to the listy example at the top, as I mentioned to you, that is currently with the next pointer in there. That's not actually implemented.
Your intent is to implement this.
There's a to-do in the code. It says this should return true if it's read-only, because that eliminates the variance question. So it's difficult to have a read-write there, at least not without a runtime check. So again, these are language design choices,
That's
right?
interesting. That's another restriction, because in the general case, of course, a listy could just be any one of list 1, 2s, and 3s in your next field.
But if you go back to your class list 1,
list 1 can't have
it
a list 2
doesn't say
next.
that it takes a listy. It says it takes a this class.
Yes, I agree. No, I agree. The typing rules have to be the intersection or union of both sets of rules. One of them says you got a next, got a next, got a next. That's listy. The other one says you got a next one, you got a next one, you got a next one. And both of them have to be true.
And just, it's not typically how it's done. If you asked any of our resident computer science professors and or students, they'd be like, no, don't do it this way. But we make choices on what to enable and what to disallow based on what's useful, not what's in the academic materials.
That's fine. The thing that came out of the academic materials for me was, if you don't, the guy who's doing the Cliff takes a null. Cliff is an age, not a null. Not a we, sorry, 22. Yes, I'm 22. Oh God, fucking hell. If I knew then what I know now.
The point being that you cannot declare, you have to either you have to pass something here because it's a nullable type. Either a new cam, or you terminate the chain right here. So
suppose the constructor not shown on the screen gave me an arbitrary long list of cliffs and cams and an arbitrarily long list of ticks and tocks, much longer than the 50-50 shot out of random. So I usually terminated my list not with a null, but with a cliff or a cam or a tick or a tock. That's the kind of thing I'm trying to show here. And that's the reason, like, the null isn't important. Assume the list is sufficiently large that I'll chase it some unknown distance and still have list elements of cliffs and.
But cliff doesn't extend cam, neither can extend cliff. So here the union will be object. You have to find some.
In the land of Java, the union's object. But in the land of some other typing system, the unit would have a next field, like list, like the
You mean
link
the
guide,
structural? You mean
right?
the
The interface
structural?
link, which just has a next field. No, that's fine. And then I've unified cliffs and cams. If I only filter it through this, you just have a next field. And that's standard Hindley-Milner typing will pop that out. So I could pass, you know, cliffs and cams to a linker that a link code that just chased a linked list, like counted the length of the list. Like, I don't care, you tick tock cliffs and cams or ticks and tocks. I can tell you the length of that list without caring if I'm cliffs or cams. Because I just need to chase next fields till I hit a null.
You need to count on objects. You do nothing to do with.
And if I know there's a value field, and here I have ages and dogs, which is different. So for general edification here, in the land of structural typing, the usual presentation under the hood is a graph where the edges are named by field names. The edges in the graph are named. If you're nominative, the nodes are also named. And if you're nominative, because your nodes don't confuse, you typically can't get into these bad cases. You must match the names. The names are given to you. Like the list one mentions list one, you have the name in your face. So you just tie it off by the name, and there's no recursive interesting thing, no cyclic thing that's interesting.
So 99% of the time we rely completely on non-native typing. The reason we chose to incorporate structural typing, or as it's generally known in the field, duck typing.
No, you got it.
The reason we
duck typing is the runtime version. It's the Python version. That's what I understood it as.
Yeah.
You got static typing.
I have not heard that definition of it, but duck typing I always heard is, you know, if it walks like a duck and quacks like a duck, then it's a duck.
Yeah.
The problem is when it happens. And the duck typing, you assume it happens at runtime.
Well, ecstasy is statically typed, but not all types are known until runtime, so it's not as clear of a distinction. So we prove out at compile time that the code as written is type safe, but it doesn't mean it's always going to be. It doesn't mean that there aren't any unexpected type errors at runtime.
Hey, Levo, you have a question?
Oh, I was just going to say, I don't think I've ever used duck typing in my entire life. So I just found that a little funny.
You write Python code?
I'm not surprised. But if you've used C, you've used duck typing. I mean, it's impossible to not use duck typing in C.
In C?
Yeah.
No, you cast.
There's no type in void, so
you cast in C. That's naming. That's not duck typing.
But the fact that an int is also a float is a duck type. Yeah.
No, that's a union rule.
Yes, whatever you want to call it, casting, union, you can do it.
No. Casting's different than union.
I can cast it via void star, and it's the same.
That's not duck typing. That's like duck mutilation or something.
Yes. Okay, fine.
Not duck typing.
So the reason why duck typing is valuable in a higher level language is because you have library boundaries and you have versions.
So yeah, fine. You don't care when you cross the border if you have all the right fields for the library call.
Exactly.
Yeah, and that's the reason that duck typing is exciting. Yes, I'll agree on that one. All right.
So yeah.
So all I was trying to come around to is if you throw an arbitrary false at some point in your code in your recursive depth, then you don't have the general graph equivalence problem. The solution is a straightforward trivial graph walk. All life is easy. Carry on.
No, what I'm saying is that we get to the point where we prove that it's ABA. Like we know that these things shifted one either direction is fine, right? It's like everything lines up perfectly. Therefore, we have a choice. We know they're not nominally the same. We know they're structurally equivalent. We have a choice, though, whether to say that they are that the one type is the other.
Right.
And right now we choose false.
Right.
Mark, I blamed it on you. I think you and Gene made the decision.
The problem you have here is that
That sounds familiar.
Hand you a more complicated type structure, you will not be able to say that they are equivalent or not at any point during the walk. You'll never find the point where it's obviously that they're equivalent or not. except via, I say no because I looped back on myself. I went to A to B to C to Z, blah, 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 Z, back to A. Oh, I looped. Over here on the other side, I went A, B, C, D, E, F, G, back to A, I looped. Are these two equivalent? They might be. You can't tell without doing.
So that's not how we do it. So what you just described is a different algorithm. It's
Well, if I
more
have two guys, and they
right.
both say, you have a next field. Oh, go to it. They both have a next field, go to the next field. Go to the next field, next field. Okay, one of them's 26 deep in cycles, one of them's 5 deep in cycles. And I can take the 5 deep guy and cycle him 25 times, and I'll get back to the same point.
So we cycle them together, so we're
Yes.
never 25 versus 6 or whatever.
Right. So as soon as you say one is 6 and one is 25, and
But we don't say that.
Well, okay. So the guy got ABA, one's got ABCA. We both go A, A's both got an X. All right. We both got things, they're interfaces, so I can't say the name of the thing, but they both got nexts at the B point. I go to the next one. One of them went back to his A, one of them's at a C. One of them is cycled, one of them hasn't. Do you declare false at that point?
You seem to be talking about instances, and I'm talking about types.
I'm talking about types. I have a type I've called interface A, except I'm not doing nominative, I'm doing interfaces, so it's all structural. And I have a type I've called interface B. A points to B, points to C. X points to Y, points to X. One of them's a cycle of 3, one's a cycle of 2. A, B, C, A, B, C, A, X, Y, X, Y, X, Y. Now, A and X, they both have next fields. They look equivalent, they have nothing else. Next field, okay, go. Y and B, oh, they got to look at next fields, they look equivalent, go. Z and X, they both got next fields, go. Or not, because one of them cycled, one of them didn't. And then one goes to here, and now I have an A pointing to a Y.
Yeah, so, but for each pair, we determine the compatibility.
Yes, and I'm asking, what do you do?
No, I'm saying each pair is its own branch of recursion.
Okay, so I have the AX pair, I have the BY pair, I have the CA pair, I have the AY pair, I have the BX pair, and then
Yes.
because it's 2 and 3, and I did the GCD, greatest common denominator, I eventually loop around. I have 6 pairs, and I found a hit. Is this the algorithm you're using? Do you think you don't know? You can say I don't know.
To the best of my knowledge, we exhaustively search the graph.
Okay.
with
So I can
pairs.
hand you a case where that exhaustive search will go badly exponential really quick on you. And you
Yes,
will
of
never.
course, you could create enough types in that graph that it becomes an exponential problem. Yeah.
Yeah. Whereas if I did a DFA minimization, it's basically n log n and it's done. But it also means that you have a non-trivial answer.
Yeah, I don't know if I have I don't know if DFA was used in this or not. Because
Yeah, I suspect you would know because there'd be some bitching and moaning and some conversations around it. I can't imagine you wouldn't know.
it's a good question.
Yeah, fine. Yeah, we can ask Gene.
Yeah.
What
He's
I'm
at
really
lunch.
coming around to, Cam, is if I go implement a type matcher here, I'm likely to fall over exactly the case, and I'm trying to sort out, do you intend? So I didn't show that example, but I could actually A, B, C. Here, I'll write this example here, and we'll see the DFA, min algorithm go. It won't show up. It'll get ugly here. Interface, and you can imagine extending this. A has a B question mark next field, and I don't care what else. And B has a C. And C has an A, and there's my cycle of 3. Okay, now I have another one. X is a Y. And a Y is an X.
Yeah, we would very quickly show that A and X are not compatible here.
Okay, yes, and I'm asking, where exactly you show and why you show they're not compatible. It's fine. It's a good answer. They're obviously equivalent. If I have anything of an A's and an X's, I can also swap them back and forth because all I can do is fucking ask for the next field, and they're all equivalent. But Now,
Well, no, I'm
replace
saying
this with.
I'm saying they're not equivalent. A and X are not
Yeah.
equivalent.
Yeah, and why do you say they're not equivalent?
Well, because I look at it and know they're not.
Okay, but that's nominative.
But no, I'm sorry. When I say look, I mean, I see the infinite recursion in my head.
Yeah, you see a length 3 recursion, a length 2, but if I replicate the 3 twice and the 2 3 times, they line up again and I'm perfectly aligned again after, a mod 6 count there, and they're all the same. The DFA minimizer will totally pop this out and say the correct answer is an interface of ABCXY goes to an interface of ABCXY with the next field, and that they're all otherwise the same. It would unify all your states in here and say, yeah, it's just one big state with the next field. It's your list example I have, your link example I have above. It's all just the next field. Whereas I'm going to do all pairs algorithm would painfully slowly, I think, get to the right answer with exponential pairing.
So the right answer, you're claiming the right answer is true or false? This is what I'm.
Well, no. I'm claiming that under a certain set of rules, you could claim these are equivalent. And the set of rules are, what can I do with the thing that I have? Well, all I can do is ask it's null or it has a next field. That's all I can do. I can ask that same question of every one of them. They have nothing distinguishing between them. They don't have a dog or a cat or an int or an age or anything. I can't tell them apart.
Mark to weigh in on this one, but to the best of my knowledge, we would look at this and know for certain that it's false. This is not the gets to the end and we make an arbitrary decision because we wanted to keep things simple.
Yeah, and I'm asking, what criteria are you using to say they are not equal?
Well, because what's that called in the period is different.
Okay, so you find the back edge on the XY pair ahead of finding the back edge on the ABC triple.
If I know any of the words, but
That's, that's kind of what I recall us deciding on. Although in this context, it does feel wrong. But I think in terms of like we had to do something as an implementation, it seems reasonable.
Yeah, what I'm pointing out is
this one is the provably false. Like we look at this and we say it's false. The other one where the A returns B and the B returns A, those were like we get to the end of it and like, well, can't prove that they're different,
right?
But we'll say they're different.
Oh, and yes, but the one with the cycle length being the same, you could have said, or we'll just assume the same because they don't got any counter proof that they're different. And that, by the way, works.
So the cycle length, meaning the period.
The period, yeah.
Is, in this case, is 2 versus 3.
Yes.
So we, to the best of my knowledge, again, I didn't write or work on this part, but to the best of my knowledge, we look at that and say, nope.
Yeah, okay, that's fine. Now, I can obviously from here, crank this example up to arbitrarily large, strongly connected components in both sides, and then ask the is a question. And that gets you to the arbitrary. Take these two graphs are the equivalent, and that's the DFA min algorithm. You have cut yourself off on a trivial cycle, but I can even take the trivial cycle case and bust it up also. Because I can add 2 fields and you can be cyclic on both of them and they have different periods on all of them. And now what the hell do you do? Or same periods or something. It could get ugly here as well.
Yeah, but the period for us, the period difference detection is an automatic no. So we short circuit at that point.
So you cut, and that's totally fine. That's what I wanted to know, by the way. It does tell me that I have a fast linear time algorithm that's simple to implement to do type equivalence under these set of rules.
Cool.
I'm so glad I don't have to think about any of this.
Well, if you go with nominative typing, you also don't have to think about it. If you want to add interfaces, which many people find very useful, this problem shows up and there are different answers. And I actually don't know what Java does.
Java does nominative only with interfaces, which is also a reasonable answer.
In structural only with interfaces? Nominative.
Nominative only.
Where does this come up in Java?
It doesn't. That's the point. Java doesn't do structural. Java does not do structural typing. So in this case,
I think you're right.
In none of the cases is a return true with Java is my point.
Yeah, I can't define interface A takes an interface B, and then B takes an A. I cannot write that in Java because one of the interfaces has to be first.
Actually, you can
that
write
you can
that in
write.
Java.
Can?
You can write it, but A is not B and B is not A. That's the
Yeah,
difference.
there's no duck typing in Java.
And that's, okay, yeah,
So
fair
you
enough.
only implement the interfaces that you explicitly say you implement.
You're right,
Or
and
that
that's
they
nominative.
explicitly say that. It's all nominative the
Yeah,
whole
it's
way
nominative.
down.
Okay, yeah, I'm with you.
Which is a reasonable, I mean, it was a beautiful, simple design when it came out.
Oh, yeah, no,
43 years
nominative
ago.
short circuits all these issues here.
Yeah.
I was planning to do similar. You have to say you're implementing the interface. There's no inference happening the way I
Wow.
want it.
A totally, totally good answer. Oh, I see what's going on here. God damn it. It's Google Docs versus my mouse versus the Google Docs mouse.
So I'm planning to have my language used in very complicated programs, and I don't want accidents. Accidents like if two things look the same and they're treated the same, even though they're not meant to be the same. I prefer that to duck type it or just say they look similar enough. So I plan to be very strict in a few places in my language.
Yeah.
Right, but generally speaking, you're not passing random arguments to random methods or placing them in random fields. That's so, don't confuse Cliff's purposely confusing examples with reality. The reason that duck typing is useful is because going across a module boundary, you may not have the interface that you need to implement.
Yes, right.
And after you've lived through that, as I have in Java, if you don't have duck typing, you can't make that complicated application that you want to build. So, a lot of my decisions are based on scars that I experienced building applications or helping people build applications. Duck typing is 99% idiotic and 1% essential.
That's good.
So just to complicate your life, Cameron, there's an example where I've got cycles of length 2 and 3 in the same type.
Yeah,
So,
and again, we would detect that if there's a conflict, we would detect it pretty quickly.
On the first shortest cycle that conflicted.
I think so, yeah.
In one would not conflict for A, B, and X, Y, but the C will conflict. And then the C conflicts itself with ABC as well. So you probably would blow that off.
So I used to say in distributed systems that you can never prove that they work. You can only try to prove that they don't work and fail to do so.
Yes.
And it turns out that in type checking, there's actually a similar concept, which is you can't necessarily prove that two types are the same. You can only try to prove that they're not and fail to do so.
Okay, here
And I'm gonna just say that's I didn't implement it, so I'm only describing what I've seen.
I hear you, but I'm going to claim that having gone down this route and all the way to the bottom of the rabbit hole and back out, there is a strong definitive answer. You can prove they are equal by proving there cannot be a no.
That's it. Sorry, you just said the same thing, but you're trying to sound smarter.
Well, I'm saying
that's not fair. That's too easy.
You've proven no, not you didn't find a no. You've proven no.
Yes, no, that is what we do.
Okay.
So we get to the bottom of it. We prove there's no, and then we say, well, in this particular case, we choose to say no anyways. That's
because the cycle length's different, which is
no. In the cycle length different, that for us is a hard no.
Oh, I see.
I'm talking the ABA.
Yeah, why do you go up on? You just gave up on ABA because it had a cycle.
No, we don't give up. We get to the end. We prove that they're not different.
Yes.
And then we say
no, so you give up. You say I give up.
We say because it's this alternating. Again,
pattern.
Mark was involved with the decision, so
okay.
I didn't agree with it, but I was outvoted.
You bottom out somebody. You hit the recursion end, and you find the back edge in the cycle. And you say, because I have a back edge in a cycle, even if you had a back edge in a cycle, I'm done. We're just gonna blow up.
So originally Mark came up with the example and we plugged it in and it worked. And then Mark was like, oh, I thought I was gonna like the fact that it worked. And actually in retrospect, I think it's a bad thing. So yeah. but I can't remember the full.
That's
This
fine.
is 5
I
years ago.
got the answer I
You
need.
you remember more than I do. But that sounds like me.
I just remember you were at the office at the time. We were doing a review on it, and yeah.
And I'll add that while I was working on this in AA, I didn't know that I needed this or could. I just kept finding more complicated cases that seemed to ought to work and didn't. And I kept trying to sort out where it was. And I kind of fell into, oh shit. And then I read all the papers and they said, must DFA min, so don't bother. And then I had some guy, a good guy, produce me piano arithmetic in the typing system. And I was like, oh, that should work, but boy, that's ugly. And then, oh God, you have to do everything. You have to do the cycles and whatever. And then when I did the cycles, I can do piano arithmetic in my typing system. It's like, really? Twitch, okay. And it's fast. It's simple, fast, not simple, it's fast. DFA min's not a slow algorithm if you little care. But I definitely surprised myself. It was not a thing I thought I was going to have to handle when I was designing the AA typing.
Yeah, I'm not surprised you ended up needing it because you're structural first.
Yeah. Yes, I'm structural first.
And we're structural because we felt we had to.
Because you wanted to pass the types
Because of the
module.
module issue.
Yeah.
Well, because of the dependency complexity that you get if you have to do something without having duck typing available. It gets
Okay.
ugly. Yeah.
Right. But that does mean that you have structural typing, which does mean you now have to answer the question, when do I give up? And the give up is either you hit the DFA min algo or you pick an arbitrary cutoff point, which in your case was back edges. Or an
Yeah,
arbitrary cutoff.
I'll let you walk through it with Gene and Mark or Mark at some point, and you guys can figure out if we implement a DFA or not. So
I'm like I said, I'm certain that you would know if you had. Gene should be able to answer that one off the top of his head. And if he can't, what the hell are you talking about? Then no, you didn't.
I'm sure in Russian it was not called DFA. So
Oh, this was a type theory question. I'll bet you Russians are well familiar with it. This is an
I think if we implemented it, we invented it or reinvented it, not knowingly
it's
implemented
not
the
an
pattern.
algorithm that you would accidentally invent in the code. Like I would be very surprised if you accidentally invented DFA.
you'll be very surprised very often.
Remember that time we accidentally invented Paxos? That was fun.
Yep.
Yeah. I knew better at H2O when I tried a bunch and I was like, okay, it's time for Paxos. And I was heading that route, but then Paxos, fine. Yes, you could do that one. That one I think
I got a database question for later.
well, I think now's a good time. I think we're winding down here.
Okay, so I know a lot of people have difficulties dealing with like unit testing with databases. I heard only one person have ever said this. You should be abstracting out the inserts and your database queries, so you can test it without touching any database whatsoever. But to me, that feels a little weird because you would want the inputs to be your query. So I was just wondering, is it a good idea to abstract all the everything else completely, or is this like the wrong way to go about it? Because personally, I use SQLite for testing, and it has a memory database. You can use it in raw memory, and you don't have to touch this. It's super fast, so I never had to deal with it. So that's I was just wondering
Certainly when I was
unit test
doing
it.
test case proving on, this is fintech data stuff. We had a database involved and we definitely would spit up a mini database in RAM only, pre-populate it with what we cared about, run against it and confirm we got the answers we expected out. That was just part of the normal testing harness. Like she said, we mocked up, but it wasn't a mock, and it wasn't SQL-like either.
Was it copying a pre-populated database, or is it spitting out a completely new one?
We did some work at optimizing test code on things and parts of the test we didn't care about. I don't think we took a pre-popped database because it was too easy to screw up. There were some big ones that we were read-only that we did take, and those were, I guess you could call them pre-populated. We should never touch them. They contained all kinds of weird shit about the nature of fintech queries are all over the planet, time zones and stuff, but the ones we were using sort of locally that we expected to mutate, we made one, filled it, tested, looked at it, made sure it made sense, the answers got back made sense, and then threw it away, and that was all part of the test. And it was cheap enough, as you point out, it's cheap enough to make an empty in-memory only database.
Yeah, and it
Test that
sounds
spot
good.
Yeah.
But the way I've been using, I did many queries on the one database. So I was just thinking that could cause accidents, but I don't know. I didn't try to do any randomization, and I know you're a fan of randomizing your unit testing.
There's a bunch of stuff there, yeah.
Yeah, I want to try that, but it sounds interesting. I'm not sure how to do it, but I just haven't thought about it.
Now that you said that, I'm wondering if you loaded up a more modern database and ran a bunch of queries on it, a bunch of tests, and the database internally optimized for those queries, you could trigger some kind of bug. Either its optimization was buggy or not, or performance was wildly different or not. And then when you ran your actual code against the actual database, his performance was different because the
interesting.
query setup. Yeah, I don't know.
Usually I'm just concerned about correctness, which sounds weird since I'm always about optimization.
No, but if somebody optimizes and they're doing it wrong, then you can find a bug in one scenario and not in another. You never see the bug here, you always see the bug there. But it's not your bug, it's somebody else's bug because you're triggering their complicated behavior.
That's an interesting thought. I never tried to optimize off of a test database, so that's an interesting thought.
Well, no, I'm saying the test database internally itself self-optimizes. You ran this query once before, we're going to hand it back to you from cache.
I see.
Right? Oh, we got a caching bug because you're supposed to have mutated because you didn't know the right to change the database. The query should be whatever. In other scenarios, the cache got flushed all the time because other things were going on was enough to flush the cache, so you never got the same broken query back. I mean, I don't know if that's the issue or not, or whatever. I'm just sorting out like what you could run into.
When I get closer to version 1.0, I'm gonna try to get some kind of testing framework into my language, and I'm gonna try to get it to randomize because that sounds like it would be a pain to figure out in production.
The whole randomization thing is a variant of fuzzing, which is a useful technology for compilers testing. Just ponder like building a fuzzer for Bolin. I'm not there because I have plenty of broken code in front of me, but I'm definitely planning on putting a fuzzer for AA together at some point.
So one of the issues I have is I would like to have 100% line coverage because for my runtime, I do have 100% line coverage. And then sometimes, or at least for some of the functions, I do 100% branch coverage. And I know that's like not, I know you can get false confidence because of the input data. Like you just didn't vary your input wide enough. But anyway, I'd like to do that. But for the moment, I have a bunch of nodes that you can't really cause an error. But I wrote the error handling, or not the error handling code, the code that reports which part of the line it's at. So I have all these lines that are not executed, and I don't know how I should tackle that. I think I should just mark all of those as like exclude. But yeah, I have a lot of code that I don't want to exclude, but I'm not sure how to test. For code that actually produces a value, I do have some syntax that lets me test it, but I don't have that for like global scope in certain nodes.
I mean, you should be able to write those test cases, but then you got some work to do. I don't know.
One of the things that bother me a lot about the coverage tools is I can't filter certain things out. One of the coverage tools, if you, I have a class that I use with the template, and uh, let's just say both templates are unsigned 64 bits. We can call them as two different enums. One of them I do full coverage on. The other one I use once, and I'm getting all these reports that I didn't check every case because that specific instance had a line that wasn't tested, and it's just really annoying to see. So I tried using GCC's coverage, and it was a lot better. But yeah, coverage tools I feel like can get like a lot better.
I haven't used them very often, so.
I bet the Java ones are a lot better than the C.
Oh, that may be. Yeah, I don't know.
Yeah, it's surprisingly painful going back to any of the C toolchain stuff after working in C# or Java.
It's amazing that all this money was spent on like C, and the tools are still not there.
It's not that so much as under the hood, a lot of those tools haven't been changed in literally 50 years. Like a lot of the tools are like you just dig it, it's like layer cake, right? So there's still stuff under there that hasn't changed in decades. So you know, Java was built what 20 something years after C, so they had ideas about what metadata to include from the beginning. So the metadata was part of the specification, where in C, it's like, yeah, every tool chain had a different set.
No, you stripped most of that info out. In the optimized builds you were trying to run in production, you stripped all that data out anyhow. That was part of the normal spec.
Completely different thought. So do you guys know anything about Mojo, the language?
No, not me.
Yeah, it's got a cool name and symbol.
Right, yeah, I've seen the name and the symbol. It didn't help.
It's the best. It's cool.
So from my understanding, they're trying to be a superset of Python, and the idea is just to make all the data scientists and enterprise code that doesn't really have a Python programmer writing Python to do like AI training or whatever. They want to make that code really fast, and I'm guessing they're going to sell support.
Yeah.
I'm not sure what they're going to do with tools, but also AI. I don't know if AI is a good idea anymore because there's like 1,000 startups now. But do you guys think it's a good idea to do something similar that Mojo, or not me doing something similar, is what Mojo is doing?
You asked me if I think Mojo's business case has a hope?
Has a hole or anything, because it seems suspicious that or I'd rather make tools than sell support. So I don't know, and I don't know if people who write Python want
Here's
support,
here's the magic trick, that the evil secret of the tool industry. No one fucking pays for tools.
Yeah, I figure.
Every programmer on the planet, they have no money. They cannot pay for tools.
They have no budget.
They have no budget. That's why you mean no money. You're right. No budget. They have no budget. They cannot pay for tools.
Yeah, they
So
can.
does
They
that
can,
also apply
they
to
can buy
support?
expensive houses, but they're not allowed at work to buy a book.
Yes. So you have to sell something to the corporate. It's an enterprise sale. This is H2O's business model. We made a cool tool for doing big, fast calculations that was a, you know, eye candy and speed candy for the data science nerdies. But the budget was all in the hands of the corporations, who would decide to pay or not pay to give their guys a tool for doing bigger data. And you know, that was typically the data scientists would download the free version and screw around and decide it was good. And then he'd want to run a big one, and that was also fine. But when it went to production, then you had to pay us money.
So as long as the company can convince the enterprise people that their code will actually be whatever times faster that they claim,
right, it has to solve a problem. And if you have speed as a problem and it solves it, then you're willing to pay.
All right, I'm gonna keep that in mind. Yeah.
a kind of useful metric is you need to figure out what it saves the customer. And he'll give you some fraction of what it saves him as a money, as an annual fee. So
But technically that applies to tools.
Sure. But the
Which no one has the budget
tools,
for.
the tools make an individual developer more productive. But the individual developer doesn't have any leverage to explain that, any hard and fast numbers to show that to his boss or his boss's boss. At the Silicon Valley, explosion of whatever 80s and 90s, some of that got better, because certainly when I grew up, you didn't have budget for shit like a new monitor. Somewhere I got out to Silicon Valley and people were like, holy crap, this is stupid. So of course you spend $1,000 on a programmer, their salary's 120K, 1% one time, it's like no brainer. And you buy them the wall of monitor, and they plug their laptop in because they like their laptops to go home and come back. But the work, they got a wall monitor. And you give them headsets so they don't have to hear their neighbors, and you give them whatever, and you give the stock room has candy and coffee and more coffee and all caffeinated beverages on the planet and whatever. These are all cheap ass things compared to their salary that you could fairly well track to being more production or faster programmers. Whereas the programmer who says, I'm a DevOps, data scientist, and I'm like trying to do whatever, insurance company, annuity tables or something, trying to do risk in Santa Cruz Mountains for homes, like everyone's bailing out of the fires and we have the wettest year on record forever, but we can't get fire insurance. We can, but we just barely squeaked under the wire. So anyhow, somebody's doing some risk analysis. In the small, on his desktop, he gets one model number. He knows if he gets a big data, he'll get a different model number. At some point, he wants to rerun that risk analysis on a regular basis. And that needs big data. And now he tries to sell to his boss. Okay, we'll shift our risk reward trade-off by 10% if we pay money to these H2O guys. And since the $1 billion in payouts every year will drop by 1% of that because the risk moved by 10%, we'll save $10 million annually. So we can give H2O $1 million annually to save $10 million annually, or something like that. That's sort of the mindset you go through when deciding will you pay, why you would pay, how much. Or at least that's the mindset I work through. I know Cameron uses a lot of bottles of wine for some of his, so I don't know if he has a different answer.
So in short, you don't sell the tool, you sell the idea.
Wine works well.
Yeah, right. Yeah. I and I'm not that guy.
So
If I'm go ahead.
okay, so I was trying to figure this out. So I was like, suppose I make this amazing language and I implement all these fancy optimizations in the compiler. And I don't know, I didn't find any good numbers to use. So I just assumed it'll be a 2x speed up across the board. Like whatever program you put in, you use my language and my compiler.
Right.
And it'll just instantly get 2x faster.
Right. Magic pixie dust, 2x faster.
And so so I was trying to figure out how much money that was worth. If say Google were to adopt it.
Zero. Not worth rewriting my entire code base in your language to get a 2x speed up, literally.
But they'd save half the hardware, right?
Only if that's what their binding costs were, plus a huge ton of risk. At H2O, we kind of saw numbers between 5x and 10x speed ups, not 2x, was where the breaking point was. Geez, okay, we'll take the risk, we'll rewrite all the code, but we had to have a giant ass speed up to get anyone to budge. Maybe it's better now because the tooling's all more stable and people know what's going on. But when we started out, boy, if we couldn't show 10x speed up, no one would bother.
Yeah, that's pretty common. No one's going to change anything for a 2x improvement.
Yeah.
Let's say I'm completely clueless and I have 1 million users. Let's just say 1 million, okay? But I'm completely clueless. Would I still be able to figure something out if I have 1 million users, even if,
Yes.
because I might not know why I have 1 million users. I just
But you
have
don't
them.
have to. If you have 1 million users, there'll be people knocking on your door
Yes.
saying, hire me to tell you what you need to know and I'll take all your money.
Yeah, and you can make sure you get some of that money, but they'll be like, sign a contract with the DOG to go investigate, write Bolin code. Help our programmers write Bolin code to go solve this problem. And now you're a consulting firm.
So as long as I can figure out how to get 1 million users, I should have no problem after that.
Yeah, you'll find money. It'll come at you somehow or another. Yeah. You have
Okay,
to-
yeah, I should just focus on that then. I'll do memory safety sometime soon.
Right.
The
Yeah,
thing
this
that
is-
everyone talks about is how are you doing the memory safety? I should jump on that. But my
Yes.
tool is not even useful. So even if I do implement it, it's like you can't do anything with it. So
So there's
you need to rename
another.
your language to Jomo.
There's another path forward here that's longer and more reliable, and that's you solve the memory management problem in a useful way. People love or hate Bolin, but everyone loves the memory management solution you have, and they all implement it. And your name goes around the world as, hey, this guy solved this problem. And now you'll get a job. Somebody will pay you. Wait, we're going to hire Microsoft. We're Microsoft. We want this in C#. We are going to pay you fucking $200K a year, and you get a big ass salary. Stay in your favorite city, wherever you want to live. We'll pay you $200K a year. Go implement this in C#.
this is what I believe, but I don't actually know. The reason why I'm writing my language is because I absolutely know no one else can implement it. So I just woke up one day, just after reading some news, I just figured out literally no one can implement this. So that's the only reason why I bothered to write my language.
What is the Jomo language here?
I thought that was a joke, like jumbo but I didn't pick up what the joke was.
Jomo is in Mojo, sorry.
Oh,
Oh.
Mojo. Geez, your Lixdexia needs some fixing here.
No, he can't use Mojo, that's taken.
Nah, I kind of like the name Bolin.
But the flaming ball of fire, it's all fine. It's just all on fire. That's okay. That you can use that one.
That's the Mojo symbol. Well, they can't copyright that. That's an emoji.
How else do you say you're blazingly fast?
No,
Yeah, I mean,
it's the
you could always use the poop emoji, but I don't think that would work.
no. Where's the one where the dog's saying it's all fine?
I'm just
we
thinking
all know
poop
that
emoji
name.
and Bolin. There's a combo emoji there somehow. Sorry.
Yeah, I have no idea what I can do for like a symbol or icon or anything.
There you go. I threw in the it's on fire one in the doc.
There, I gave you a logo.
Going Bolin. Okay. Yes, sir.
I'm here all week.
Yeah, and there's balls of turds at the flaming balls of turds at the far end of the bowling alley that you're trying to strike on. We should stop. I should stop line behind because I'm getting behind her.
I knew people were gonna make those kind of jokes.
All right, something different. How to make money with a programming language.
You can't.
Step one, write it. Step two, question. Step three, profit.
Profit.
Yeah.
You got to get over that step two.
I never realized this until so a guy had me and Ginger Bill on a voice call, and the person was saying Bolin and Odin multiple times, and then that was the instance I realized that they're kind of similar. I had no idea.
Oh. There's another programming language I haven't heard from in a while. Odin.
Yeah, I found it interesting, but I haven't written a single line of code.
Well, I get the Odin the god, Odin language. How about that? Oh, there it goes. Odinlang.org. Programming done right. That is true of everybody who ever writes a new language. Programming done right. I see nothing in this programming language so far that looks exciting. It's the C alternative. Okay, yeah, do I want docs? I want demo, probably. About overview.
I'm
We're
kind
gonna
of
have to
curious.
buy, we're gonna have to buy Cliff a copy of OBS so he can do this all day long and post review
Oh,
videos.
no, I don't
Be a
have time for this.
streamer.
This is my 10 minutes per week of staring at other people's languages.
Yeah, I've never used it, but I love watching his videos. He's a funny guy.
Excellent. I probably should watch the video instead and not do it while I'm online in coffee club. That's probably makes more sense. Okay, what else?
One of the things I've been wondering is how many language implementers and designers have been hardened by C and C++? Because it seems like many languages is to get away from C++. And I might be the only one that's very, very comfortable with C++ and still enjoys it.
There's a lot of folks that are comfortable with C++. That doesn't mean
And
they're not
implemented a
language.
language.
I'm sorry?
But how many of them are implemented a language?
No, I suspect a fair amount. This is a, you know,
Oh,
if you're into the techie low level details long enough, at some point you're either wanting to write an OS or you're wanting to write a compiler for a language for a compiler. One of those two seems to pop up kind of commonly. So you grab a, you know, whatever, the little tiny guy Zig Lang's running on a Raspberry Pi, that's what I'm looking for, and you write the OS for a Raspberry Pi or something like that.
I wanted to do something like that, but I couldn't figure out some of the drivers. So I figured that maybe I would just try with an Arduino one day.
There you go.
But I don't know what kind of hardware I can use that has decent resolution and not a driver that requires Linux or Android. Because every time I looked at ARM, they say you have to use the drivers in Linux or Android.
I would go to something simple enough that you can start writing the drivers yourself, because that's part of the joy of writing an OS is understanding what the fuck a driver does.
Oh, I want to stay away from drivers. I just want to write everything except for the hardware specifics, because the hardware specifics will always change, and I would want to optimize something really hard. But if not everyone's using the same hardware, it's going to be a huge disappointment to me.
No. This is a learning exercise. Touching the hardware at least once in your life, where you're actually scribbling on registers that are flipping bits on a screen or cramming down a serial port or whatever, it's a useful exercise.
I did an emulator once, and that was really, really fun. Actually, I did in high school.
It's changed a lot though, Cliff.
Yeah, it could be. Maybe I'm all wrong. It doesn't look the same.
No, I'm just saying, you know, you have buffers now and then you ship them off and let someone else handle the actual.
Well, right. So I've seen there is a microcontroller buried inside, buried. There's like 3 layers or something stupid for all the handoffs. And I grew up in the realm where you wrote what is now in the microcontroller. And the microcontroller is a computer chip much smaller than my fingernail, is a tiny little dot. And you can't hardly program it, but you can kind of sort of, like I've worked on embedded IoT devices even recently. But you're right, there's a 1-layer handoff to what I would have said was the base level driver, where I did buffer things to this guy. But still, doing buffer things to that guy was interesting. This was me doing location services.
Serial ports you used to actually control the signaling on.
Yeah.
So one of the jobs I had was working on an embedded device, and we originally started on a Raspberry Pi, but it used too many watts, so we switched to an Arduino. And I was like reading the source code for one of the drivers, or one of the code processors or chips or whatever. You can tell that the person did not know how to write code, because they were using a loop to set a couple of bits, and you could just put in a temporary variable instead of call a function a dozen times, and it was very strange to read that code. So
get there and write it yourself. The other piece is the same guy's writing code that he ports to 17 different flavors of microcontrollers. So he has a function call for everything, so he can intercept at the function call level instead of naming the variables, because it's different for every one of the things he writes a driver for. I mean, I don't know. I can imagine you're looking at a C version of an API for a portability layer. Like hotspot has a portability layer that's kind of ugly and not well defined in terms of it's all in this one tight little place. And you just have to port these parts to port it to, no. It's not nothing so simple as that. But there is a portability layer. And if you worked on the thing long enough, you recognize, well, here's where we did like atomic memory barrier portability bits. And here's how we did the stack crawled up or the stack crawled down. And
the specific function I was looking at was using a function to set bits, and you don't really need a portability layer to set literally a bit in an int. He was using a function to set bits in it.
Right. Yes. So imagine for a minute that you're at a high level and you have this bit set that you're going to fiddle some bits and you're passing it off to some controller. In some of your implementations, you're fiddling a hardware bit. It has a memory access point, but you can't treat it like normal memory. You can't, for instance, do a read, modify, write operation because the hardware doesn't support it. So you must have a read, fiddle bit in a register, and then you do a write to update it. For instance, as an example of the kind of things you do. Whereas in some other piece of hardware, it's actually raw memory and the hardware is dual porting the memory and you can read, modify, write it all your heart's content, and you just do increment plus plus or whatever. And these things vary across the different hardware platforms. Somebody else says, actually, to set this bit, I'm going to make a function call yet again to some serial port, which scrams a bit onto an outgoing stream by fiddling and raising and lowering and timing myself. I'm going to count to 10 and raise it and count to 10 and drop it. And that's how I send the bit. And everyone has a different hardware mechanism for sending the bit. And so I just chopped it off and said, make a function call, set the bit. Oh, I'm on the cheap guy. Well, I'm going to ship the cheap guy with this portability layer baked in where I just read, modified, write, fine. Looks stupid, I don't care. Optimizer cleans it out.
Yeah, I wonder if it was something like that.
I mean, I don't claim it. Right. I'm just saying, I'm not so quick to judge these things. I'll look at it and say, that's look ugly, but then like,
well,
okay.
When I first saw it, it was doing that on integer that was on the stack. So I didn't think about maybe it was somewhere else and the hardware needed it to be at a memory location. But when I saw it, it was a stack, int on the stack, and it just looked bizarre.
Yeah, it could be. And it could also be, junior guy, hardware guy. Oh, boss says, go at the driver. And he's a hardware guy. He's like, fuck, scratch. He does something. It works. They shipped it. They didn't care. They moved on. And not his domain, always short on time. Like most things, you ain't got enough time to write all the code you want to write. So you make shortcuts and you move on.
Would you guys have like a litmus? I can't say the word. Litmus tests for if something is memory safe or not, but like in an interesting way. Because if I end up implementing memory safety, but I can't do anything in my language, I'm sure a group of people will say it doesn't count because you're not productive in the language. But I was just thinking about what I should be focusing on in the next few weeks and months.
I would get memory safety that's sort of provably. It just means that you can't scribble outside a buffer. You can't do stack overflow, return-oriented programming kinds of hacky games. Then see what kinds of programs you can and cannot write. And then ponder if you want to start extending the behavior or whatever, but get safe at all. Discover that you can't write fucking printf and you're annoyed. So you start extending your rules for safety to let more generous things go through, but get yourself safe.
As a showcase, I would consider doing closures because closures you often expose memory safety issues, especially when you have captured by some kind of reference and then you escape. That's pretty common.
Put your stack frame onto the heap, or do lifetime analysis, or prove that someone's trying to escape a closure that's got a capture, and then you just tell them no, don't do that.
Or if you prefer, you can also do coroutines, because coroutines actually will have very similar problem.
Okay.
Closures may or may not be easier.
Yeah, right. I was saying, thinking you should do closures and then implement coroutines and closures, not the other way around. But I guess Go just went straight to coroutines, maybe.
Because you have very similar issues with coroutines. When you hold on to something on coroutine frame, you are suspended, then you are resume, and that something may not be alive anymore.
Right.
I enjoyed that closer question on the Discord the other day. Matt, I tried doing that the perf memory thing you suggested last week.
Oh yeah.
I got a seg fault when I try to do set the type to load or store, but if I didn't do that and I did something else, it worked. I wasn't 100% sure why, but it seemed that branches were the heaviest parts. But I think it also might be an array that I'm loading up like hundreds of times or thousands of times. But I kind of wonder if I'm writing to memory and that's evicting the table I'm looking at, or maybe it's just a Linux going to another thread, coming back, and the cache.
Can you remind me what the context was? I remember you had some slow program with memory access.
In the place where I'm building my abstract syntax tree, I'm writing a lot of data, and I have multiple threads, and it was taking twice as long. And I thought maybe it was memory bandwidth, but when I was calculating how much memory I should be able to write, it was much higher than what I was getting. But I was forgetting that I'm loading data as well, so that might cause a lot more seeks in the memory, and I don't know how memory works. But
I even wonder if it couldn't be contention for any other resource that is along the way. For example, on Intel, you often observe slowdown when you run out of MSHRs or miss status handling registers, because they are very unbalanced nowadays. So, when you issue a request to a cache from an x86 CPU, and you do generally when you issue a load operation, you are going to want to be able to issue multiple requests concurrently, right? Maybe you have one load operation, then you have another, then you have another. You wouldn't want each operation to wait for the consecutive ones, right? Makes sense so far?
That's a good idea.
And the way it is implemented is that the hardware has to track the status of the load request you have issues. And the registers that are doing that are called miss status handling registers. And the problem is that there is very, very few of them. So when you have 2 cores versus 4 cores versus 8 cores, at some point, around even at 8 cores, especially for consumer grade hardware, you are going to run out. So you can start more and more threads, and even though you have a lot of computation to do, and theoretically it looks like you should be getting speed up, you are getting slowed down because you're gonna be bottlenecked on the number of MSHRs. At different cache level, it's also called line fill buffers, but line fill buffers amount to an implementation of miss status handling registers. So I just call this MSHRs. Anyway, the bottom line is you have performance counters for these two, so you can see whether you are stalled on MSHRs.
Could you type it out in full so I can look it up later? And when I
can just spell it out: miss status handling register, MSHR.
Oh.
You can also look up LFB, line fill buffer.
Line fill. Is there any good manuals about how the hardware works? Because I tried looking at the AMD and Intel, but they didn't really want to mention what they do under the hood of their processors. So I couldn't really find any good materials.
There are good computer architecture courses, actually. Professor Onur Mutlu, who used to be at CMU, he's now at ETH Zurich. He started to release videos from his courses. And to be honest, even going through the slides, I found that they are far more up-to-date than books like Hennessy and Patterson. So I would actually recommend the courses and the slides over these books.
Maybe
he was even talking about branch prediction in AMD Zen, where Hennessy and Patterson were just talking about simple 2-bit counters. So it's like decades apart in terms of being up-to-date.
Yeah.
So I would definitely recommend the course.
You got a link or a name?
Yeah, Professor Onur Mutlu. I can actually just put this.
Throw in the links at least.
Maybe I'm butchering his name, but have any of you read Agner Fog?
Oh yeah, that's also good. Yeah. That's also good, actually. Yeah.
Yeah. So I read that, and that's basically most of my hardware knowledge. And it was mostly guessing. It was really good guessing, but I kind of want to know I want to read some official docs, but it doesn't seem to exist. So I'm basically just going off what Agner said. But I never heard of, shit, I didn't Google it. Miss, you might have to repeat what you said earlier because I forgot to write it out in full.
Well, he's got videos as well. I was reading your cache handling paper at the first one. It's saying all the right things. It's also one of those. There's.
Oh, that's an interesting link.
I posted one Stack Overflow question which can get you started. Actually, they also linked to a microarchitectural side channel paper, and those are actually pretty good too. It's another resource I would recommend. When there is some side channel in the cache hierarchy or in branch prediction, they often reverse engineer. How does this recent AM to CPU branch prediction works, or what is the Intel cache replacement policy? And you can just read one section on the reverse engineering details. It's going to have like 1 or 2 pages out of a 15 pages paper. So don't get discouraged if the paper looks long, because often if you just want to find out how the hardware works, it's actually a very short source and up to date too. Just read like 1 or 2 pages or one section, just tell you the results of reverse engineering.
I'm thinking about buying hardware so I can just run tests on it, but I'm not sure if that's a good idea because maybe the only hardware that would be interesting would be like a server hardware with a non.
Yeah, one thing to note, some cloud providers do expose hardware performance standards nowadays.
I tried that on my current one and they don't. So yeah, I'll contact a few.
I'm not sure how many people have the matrix of Amazon offerings in their head. I certainly don't, but I seem to recall they might have had some versions with virtualized performance standards. Maybe someone remembers here. I don't.
Maybe I should start with renting from a cloud provider, but I remember the minimum amount of time for dedicated hardware was a month. So I didn't want to do it at that moment because it was going to be a few hundred. And I kind of was thinking, why pay a few hundred when I can buy the CPU for a few hundred and then just get a board afterwards and then, use it for more than 2 months.
Yeah. All right. I got to quit reading links here. This is all. Oh, I'm comparing all the Intel memory reordering games with what we went through at Azul.
Send the link because that sounds interesting.
I'm just reading the links from Matt through in the
Oh.
The Azul situation was obviously much simpler, and the hardware was much simpler in a lot of ways. But the performance gains for hit under miss cache were pretty big, and the performance gains for having 2 outstanding loads was pretty big. So we eventually got to 2 outstanding loads, but we measured like how much you could get done memory bandwidth wise by the number of outstanding loads allowed per core. And the Azul box could have 2 per core times 850 cores. So you got 1,600, 1,700 outstanding loads. There's a pretty crazy amount of outstanding.
But one more resource I just remembered. There is actually a guy did a PhD dissertation designing a superscalar out of order x86 for FPGA.
What is an x86? Wow.
Yeah, and that's actually fair. That physics has like 275 pages, and it's a fairly detailed account of this design. So that is also a good way to learn.
How many gates does that? I would have thought you'd
a lot.
I'm sorry.
A lot.
A lot. Yes, I would have thought.
Is it the 7th link I posted in the Mojo?
It's in the chat, but you can go in the docs. Yeah, I'd have thunk you'd run out. I hardly doing an x86. You'd run out. What I thought, but I guess I don't know.
I'm quite certain that the only thing that can slow down my compiler is if I have to do a ton more memory loads to implement memory safety. But if if I end up still being 3 million, then there's no reason for me to even bother
dude,
measuring.
I thought you
Wait.
said that you needed hash tables.
You've beaten the.
Yes, that's for my new test if I want to have like 10 million like function calls, because what happens is every time I declare a new variable, it has to look at global scope to see if it shadows anything. So if you have 10 million functions, every time you declare a variable, it's doing that. It's looking over 10 million items.
That's
So I gotta fix that.
quadratic. So hash table.
Yeah. So I got to get around to do that. Well, I did that hash table experience a couple of months ago. I want to do one that's memory dense, because I'm more worried about things not fitting in the cache more than having fast access. So yeah, I got to do I got to figure out.
Those kind of go hand in hand. Dense and fits in cache and fast.
Well, I wouldn't mind like having like a dozen misses.
Right.
As long as like the memory's more compact.
Right. But that just means you set your load factor really high and your table's really full. And that's your higher miss count dense. And that's, diminishing returns. And at some point your table has to grow anyhow and all that kind of stuff.
Yeah.
Go right. Wait, aren't you using is you're self-hosted? You're not self-hosted, are you? You're Bolin in C#.
I used to have my backend as C#, but it was just it took 2 seconds to make any type of HTML change. So I literally got rid of my C# and use Python to statically generate my website. So that's how much compile time annoys me. But I pay like a $5 server for to host.
I'm asking, why aren't you just grabbing a hash table from somebody else's implementation and calling it as a hash table? And close is close enough, and walk away. And if it turns out to be a bottleneck later, you can go deal, but it probably won't be up front.
Well, right now I have 0 code written by third parties. It's like it's either me or people I know. So
you didn't pick up C# hash tables then. Fine. Write a hash table.
Yeah, I figure I would have to do it eventually for my runtime. So I might as well get around to that sooner than later.
If you're going to be self-hosted as a goal,
yeah,
your library has to have a hash table.
Yeah.
Then you get into these type generics we started this meeting with keys and values, and are these equivalent?
Yeah, I'm so glad that
just use void star. Everything's good.
There is a paper, Cliff, about what we started the meeting with, and the video. When I found it, I will post it.
You mean that the Java generics can be Turing complete or something? Maybe that's the right answer. Java generics are Turing complete or something stupid. There's some horrible thing you can do.
Something about subtyping being undecidable, but I'm not sure. I have to check first.
Yes, I found it. Java generics are Turing complete. Let me see if I can get a PDF off of Arvix here. Boom, there we go.
That sounds less crazy than you were making it out to be.
Oh, having your typing system be Turing complete is not a good thing. What did I do here? Mostly because it means having answering questions like, are these two types equivalent, becomes undecidable, and that's bad.
Does that apply?
It's not that it's undecidable. It's that you're minting Bitcoin as you decide.
Yeah, exactly. That's the open question. They start the first sentence in the intro: is Java type checking decidable? This is an interesting theoretical question. And then they goes down the line. Oh, the wildcards. Oh, geez. Yes, it's wildcards. In a separate line of work, somebody shows Java's type system can recognize deterministic context-free languages. Oh, geez. That Java can try any recursive language. Yeah, they get pretty close. They might have it. They might have it. It's actually undecidable. That would be an ugly place to go. So I'm going to throw into the Google Docs this short piece of sample Java code that leads down the path of, life is bad. You don't like this. Don't do this. This is not the Java code you want to be writing. Let me go right down here to this guy. Yeah, or can I overwrite anonymous Python here? What did I get here? Yes, this is their example 5. Start counting open angle brackets somewhere along the way. I'm up to like 8 or 9 in a row near the bottom.
Yeah, so you'll notice, Cliff, we do not have wildcards or that stupid super thing.
Yeah,
Or
yeah, might save you some grief.
So that's not accidental.
Yeah. Oh, I never could make sense of them either. I have places where I clearly ought to be using generics, and I cannot get these sub, super, stars, and pluses in the right places. And I just cast. I fucking give up. Just do a cast.
So yeah, I mean, it reminds me of our conversation about Git the other day, where you had to reinstall it once a day or something.
Oh yes, yes.
Like,
Yeah.
And what's amazing is after, so Mark and I went through this with another developer, Jason, some time back, and we finally determined that and this was looking at map in Java, that basically even Josh understood that generics were fundamentally broken. When you look at the was it the put all, Mark?
Oh, that would be
Is
one
this
of
ringing
the
a bell?
cases would be ugly.
I didn't think it was. I thought it was remove where you were going.
Oh, that's right. Remove has to return object. It can't return value.
Oh,
it's like,
right. I remember
it's-
that going around.
And you start looking at some of these things, and it's and there might have been another one. Like,
Some of that was for backwards compatibility.
Yes, I remember the
But I
conversation.
think Josh
what
did
does
make the
that
comment
mean?
that like.
I remember reading why is remove return object, and it was backwards compatibility coupled with generic share. Java remove map remove return
Anyway.
object.
but it compiles as object. So
Yeah,
anyway, there's some bullshittery going on.
yeah. There's no history here. I only get hits for the Java tutorials. Yeah, fine. I'll have to hunt it later. But yes, I remember that one being why, and then the answer was because history and shit.
Yeah, but there's some hidden reasons, and what I'm telling you is some of those. Oh yeah, we had to do it for backwards compatibility. Is like actually like, no, this design doesn't work, and then a couple of places we hit the wall and just gave up and said object.
Yeah. Okay.
That's I always look at generics as I mean, I like them now, but it was the feature that for me Java went from something like I felt that I could know entirely to just like, and now I'm guessing, right?
Yes.
And I'm back to like, the C++ world of maybe this change will make it compile.
Yeah,
that was such a loss.
If I just ignore the generics, I don't care, and then I can move on. And then later I was like, a little bit here, a little bit there, and then I went hog wild for a while, and then I was like, holy shit, I don't know, star plus minus super.
Yeah,
and
I finally adopted a mode like I will not let myself cast generics away, because as soon as I'm doing that, I know I'm fixing something on the left and breaking something on the right.
Right.
And so then it really ticks me off when I'm forced to do it, like arrays of generified types where there simply isn't a way to do it.
Yes.
But and then it's just so ugly.
Do you
so
remember, Mark,
verbose.
our generifier method?
We satisfied coherence customers that wanted, because our interfaces were all maps, and we were stubbornly we hadn't generified things, and they wanted generic coherence maps. So it's like, okay, we wrote a method that took in our special cache type, which extended map, and returned it as a generified map. And what did we do inside? We just casted for them, but we did the cast, so they didn't get the warning.
It's like a pragmatic solution.
And it was just a direct assignment. It was like
It was one line of code,
but if you didn't look inside it felt magical. It's like, wow.
Yep.
That's
I
actually
swear
really
I've done
cool.
that before. I want to say I've done things like, not to a client, but in my own code internally. And these days I'm more of a mode of, as soon as I'm casting away the generic because I can't make it type right, I'm tossing the entire generic because whatever. Oh, one of my last putbacks, Cameron, to Ecstasy last week was toss the generic I attempted because it touched the signature line of 20 files and it saved me 3 casts, and I had to cast it away on a 4th place. And I was like, I touched 20 lines to add a generic. I subtracted 3 casts and I added 1 back. Oh, geez. No, stop.
Do you guys often implement classes as like a generic class, or is it mostly consuming generics?
They're different.
Yes.
In Java or in Ecstasy?
It doesn't really matter.
In
what
Java, the intention is that most developers don't author classes with generics. They
Correct.
consume
Can't.
ones,
None
and
don't, but
life
can't.
isn't as bad when you're on that side.
Okay, that's good because that's what I was hoping. So I have a problem. I guess we still have another 20 minutes, so I guess I could go into it. All right,
Yeah.
so
You had a problem, then you added generics. Now you have 2 problems.
Have a family of problems.
that's actually
It's
really funny.
parameterized now.
The opposite.
Family of type of problems.
I had templates. Notice it was becoming like C++ templates. Got rid of them because I didn't want infinite amount of problems. So I replaced it with generics. Felt like it was a problem, and I got rid of that too.
Why
So
do you
I'm
find?
not sure.
Wait, hold up. Why do you draw a distinction between templates and generics?
Compile time.
Well,
Homomorphization is probably what he means.
Oh,
Right.
when I
in
say
this sense,
templates, I'm confused at the moment.
I am too, it helps.
Were you expanding? Is that expanding them like macros?
So for templates, I was essentially doing what I think C does. And for generics, I was trying to do something like what C# does. In both cases, I did not like it. So
Yeah, it is not a simple topic. So
I thought C# generics were template-like, unlike
No.
Java. Is that not
well,
true?
they are in the precompiled option. So it does actually expand them in the whatever they call their compiled cache. But they're reified, but they're not monomorphized until they're JITted.
yeah, so one of the biggest difference is if I have templates or generic in C#, I can't say X : some inner field. It's essentially like a black box. So if I want to use the add function, I have to say, I forget what this exact syntax is, but it says this is a generic where it has these kind of fields inside of them.
I
And
mean
then
that early checking, whether you are checking at the definition site or call site. Yeah, that in C# you are going to check at the definition site. In C++ at call site. There are some constructs that are inexpressible with the early checking. So there are some real trade-offs here. You can look at the write-ups the author of Circle did, Sean Baxter, because he tried implementing both. He's one of the few people who actually tried. He worked very hard to implement early checking, and he had to abandon that effort because he missed some constructs he really needed in the language. And
is there a specific video or article I should read by him?
He has some write-up on his GitHub.
You're talking the Circle language guy?
Yeah, Circle, yeah.
Yeah, he's a smart guy.
I saw that name like last week. I don't know much about him, but like I never actually read anything or by him, so I'm interested in hearing about that. So my concern was if I don't have templates and generics, what do I have to do to not have my language be really bad? Because I was thinking, as long as I have arrays, maps, sets, and hash maps and hash sets, I should be fine. But is that enough? And do I need to implement something for something like generics, or because I don't know if many people even want to implement their own. So I figure if I just implement the core, the ones that you absolutely need, it should make 90% of people happy. But I
People
don't
will
know.
want to be able to say that their map is keyed by string and the value is, person.
So the challenge is that generics are not a feature. They're not something you add. They're not something you implement. So generics are something that you design in before you start implementing. So it changes the way you approach a lot of things, is what I'd say. It's a precursor, not an add-on. Although C++ proves me wrong, of course, which is why the error messages were always so good with C front.
Yeah. So about
I got a bigger
key...
screen out of it, right? Like I was like, the error message doesn't fit on my screen. I need a higher resolution, bigger monitor.
Yeah. So about the keying by person instead of some other field, since the language knows what a map is, that would be allowed. But I just figure I might only have like 5 types that can be generics, like arrays, maps, hash maps, sets, and hash sets. Like that's it. That's like the 5. But is that enough? Is that going to carry?
Can I write
90%
my
of people?
own map?
That's the issue. I want to allow people to do that, but I just can't think of a way because I don't want templates or generics.
Okay, yeah, that's the issue.
Have you looked into what Go is doing in its latest generics? They claim it's simple.
So actually, I was considering forcing a user to write out a specific implementation as a map, and then give them a way to make it look like it's to make it look like you're using it as a templates. But if it's not implemented by you, it just says error. I think I gotta type this out so it makes sense. So you guys could just change the topic for the moment if you want.
Well,
What I'd say though, Levo, first of all, you're asking the wrong group, because we all have pretty strong opinions on this crap.
Well, that's why I'm asking you guys.
But just to step back, I would say there's no particular feature or capability that's necessary or important. It's how your combination of capabilities fit together, and that includes everything from toolchain to everything else. It's how do they fit together to form the whole? Because what you're describing, I can imagine in some of the uses I've had would be perfect. And in others, I would hate it. And so there's not a single answer that you're going to A, be happy with, and B, that would be correct. So it's more about how the whole comes together, and does it solve important problems for people that they need to solve.
I don't know how to add a code block into the Google Map or to the Google Docs, but
cut and paste
the sample.
You take a prior one, you cut and paste it, and then you well, you've got something. Yeah, there you go. And then you cut your, yes, exactly, done.
Yeah, so I was thinking this could be a way to avoid the generic problem. It looks like a generic, but it's not actually. It's not going to blow up the way templates and generics will blow up. So you just make a concrete like implementation, then and then I can make it look like it's a template or generic. But I was thinking maybe that solution would be fine. But Cliff, if you had to write a concrete implementation of your, so you asked if you can make your own map. If you had to make a concrete version for every type, would you still be okay with it, or was that just too annoying?
Well, yeah, so suppose I'm making a map that's running a distributed key value store, not to mention H2O or coherence or anything. And I want to have keys and values that are spread around a cluster. So the map call does a hash on the key and decides what cluster member to go ask, and the cluster member's got the actual and has to go read and write members of the cluster, blah, blah, blah. There's something complicated going on with the map. Do I want to re-implement that map for every time I did one of these with a string key, with a person key, with a data frame object key, with a block key, a model key, a this key, a that key? No, I'd be annoyed. Yeah.
Wouldn't you be able to typecast most of those?
Well, so if the answer is I'm doing void star polymorphism, then I'm fine. I've done void star polymorphism all my life. It was cool when generics could do it, and sometimes they can, sometimes they can't. And void star polymorphism says I make a function call that calls the my generic map with totally void star arguments, and then it casts it to strings and persons, and I have the concrete implementation. Just what Cameron was saying was a generify function that just casts things back and forth, and I make one of those one-liner functions for each of the unique kinds of things I want to map, and I'm okay with that. It means I have a runtime cast check for every time I access a map, but that's usually not the expensive part of touching a map.
The early GCC didn't have C++ templates, but it did have libg++ templates, which were text generated.
Oh, okay, yeah. This starting to sound familiar.
Delina, who's your target audience? Because I think if your target audience is the Cliff type, right, you can get away without generics, right? We lived fine in Java forever without them, but the less deeply technical people wouldn't be so happy.
I want something that's actually more stronger than generics, or like generics are the wrong point for me. I'm either void star on the left or full on Hindley Milner on the right, or Scala, strength typing on the right. But generics landed in the middle and they didn't hit it right for me.
Yeah, I'm just thinking how to say this. So I have two target audiences. So one is like a programmer that doesn't really care what's happening behind the scenes. They just want to consume the generics. They don't want to write them. And then my other target audience is going to be like people in this group, or like me and Cliff at least, who are comfortable with, or who don't mind writing things, writing everything ourselves. So I was thinking maybe this forcing you to write it would make me happy and maybe Cliff, but I don't know if that Cameron would just think it's stupid, and I don't know what other more hardcore people would think about it. I don't know if all hardcore people would.
You know what you can look into? Have you heard of a language called Racket?
I haven't.
So Racket is a Lisp-like language. They had one feature that no other programming language has, at least not to such an extent, is that they actually have language subsets you can control. They even use it for education. I mean, one uses education, where you don't want students to use some constructs from the language that are too advanced. And you can just have a version of the language that doesn't have those constructs, and it's guaranteed that it's not going to have them when you compile the program in this language. So I think actually something like Racket language versions could work for you. It's an important mistake. I call them subsets, but these are much more than subsets. So it's not just something that has to grow monotonically in one direction or the other. You really can have entire versions of the language.
That's interesting. I think I heard Anderson say that Circle does the similar thing to that.
But I'm pretty sure nothing does it as much as Racket, because they spent like, I don't know, a decade of time just designing this feature. Okay. Others usually just slap something, quickly. They usually have some versioning when you can enable this, disable that, but there is no coherent vision of how, like Cameron said, they made it. They may have a coherent vision of how it should work across the entire language ecosystem, and they designed it so that it works. Whereas the other languages, I think, just done this as a feature that is one other feature that is on a bit of an afterthought. So I think Racket is the one that does it right by design.
Yeah, I think I'm going to look into that this week. I think maybe I should probably explain why I don't like generics. Templates is obvious because, compile time and those error messages and all the things that happen with that. But for generics, if I'm not, it seems like I would have to do something like a void star cast, and I'm not going to be optimizing it as much because it has to be generic enough to work with many different types.
But you wouldn't
So-
have any cost for it. That's the thing, because your compile time code, mainly what you would be doing is at compile time, you'd be proving that the cast is legal. Because the code you're generating is no different. It's just a frickin' pointer to memory. Like, that's all you need. There is no type in the processor.
Let's say I have an array and I'm just pushing it in. So I can just inline that into my main function because the code would be extremely simple. But
Right.
if that's in a generic, I can't do that because I would have to write more complicated code, and it would have to work across all types, or at least the majority of the types. So I can't optimize as much, and that's why I was not wanting the generics, because I
That
can't
is
optimize as
true
well.
if you have more than one type system or more than one representation of a value or reference. Yeah.
Yes, because the solution I gave out where you have to make the concrete type, that's optimizable because there's only one version of it. And you're
Right.
not going to be making mistakes. You're going to know that this will optimize the way you want it.
And that
'cause you
is
wrote
why
the code.
C++ monomorphized, is because each thing that could be a T could have a different size, or, like generate different code, etc. Yeah.
The thing that drives me crazy about templates is T is you can typecast it or implicitly cast it to something else, and you get really efficient code, but you forget to typecast it, and now all of a sudden your code doesn't fit into cache. And that just annoys me. I really don't like the templates in C or C++. Yeah. But I guess my main question would be, Cliff, if I force you to write all the implementation of every, if I made you write the implementation of all the maps you write for each type, would that just drive you crazy, or would it be okay if you're able to typecast and such?
I mean, I write maps with generic arguments. I'm not going to be interested in, I mean, if I had to do, the sort of the worst case scenario in the land of C was I just had void star arguments, and then I wrote one-liners that just cast, and I called my one-liner when I wanted the string to person map versus a, I don't know, coin to Bitcoin miner map or whatever the fuck. There's a way around it, but
So
I do
as long as
use
you can
generics.
cast, then you don't have to write literally everything. every
Yeah,
time.
right. It does, right. But I'm not interested in taking a large wad of a hash map code, cut and pasting it, and then doing a bulk rename in my editor and have 17 copies of this running around. The ones renamed keys to strings and keys to Persians and keys to dogs and keys to whatever. No, I don't want to do that. That's
So
also
I
wildly
think
slower because you're just gonna blow your iCache out.
I think what I might have to do is have some kind of like blind or I forget what they call it, but some kind of type.
Oh,
And it
we're
has to
losing
be a
you.
pointer every time, like a OPEC pointer, and then have a type that's like OPEC pointer, and then you can just use that. But yeah, I don't know the details yet.
Okay. I mean,
Maybe that's all I'll do. That sounds like it would solve your.
yeah, right.
you want
Yeah. But like I said before, C++ and those kind of things, a common, not just me, a lot of folks, common scenario was you had a hash map that took void star to void star.
And I
And
think
you
Mark
had
said Java
one-liners.
people live without generics forever, so hopefully this will be completely fine.
Right, but it was a different era too.
It was.
Oh, yeah,
I mean,
shit.
yeah. This was me doing things around. But today, I won't do that unless that's what the language only lets me get away with. You're right. I'll reach for generics for my maps.
I mean, just to be clear, Leo, like in the 80s, you could spend a week, build a software product and make money on it.
Yeah.
Yeah.
It's a different era. On the other hand, Wordle, so.
But no more pet rocks. All right.
No more parachute pants. Thank
Well,
you.
I'm just gonna say,
Yoshi.
I'm just gonna say, there's more than one languages I think is worse than a pet rock.
Okay. On this note, I think it's time to wind it down. Anyone want to throw in any last minute questions or answers? All right, go have your favorite pet rock for lunch. Bye.
See you, Josh.